out in terms of building consortia. And so over the spring, we've been working on building what I call the core consortia building pool. And so basically right now there are 25 what are called excellent sub-projects. These are European Union projects that are ongoing. And each one of these projects has a budget of about 5 million euros. They're from widening countries, and a lot of the partners and projects include Greece and Turkish partners. And so we've been working on compiling this data together in order for us to start using these partners to build new consortia. And so specifically, this call is hyper competitive. Typically, the acceptance rates are on the order of about 10%. And so my thought was that anyone who's actually on a consortium in one of these excellent sub projects, they should be pretty good. And so if you are in Turkey and you want to find a Greek partner, or if you are in Greece and you want to find a Turkish partner, this would be a good place to start. And so basically, it is a database in the format of an Excel file. So I think you can see the Excel file now, right? And so basically, on this first worksheet, you have information about the 25 different projects. And then on the next worksheet, you have information about 368 different partners. And so specifically, what is being presented in this first one about the project information, you have the ID for the project, and this is shown also on the next institutional page. And so this links the project webpage or the project worksheet to the institutional worksheet. And then you have information about the project, the teaser, the objective and keywords. This is what it's shown for SolarHub. So you can skim through these and start to understand which projects are aligned with your ideas. On the next worksheet, this is the institutional information. This is a sample entry for CERT. You have the name, you have the location, you have the category. And so for this specific Greek-Turkish bilateral call, I think you need at least one academic and one business partner from each country. And so you'll need to put this together. And so this will help you identify the type of the organization. And then you have information about the partner, which project they are a partner in. And so these up here are the titles of the projects that CERT is participating in. And then over here, you have their budget. And so I think you may kind of assume that the bigger the budget, maybe the more responsibility they have. And so in total, inside this database, we have 80 Greek and 25 Turkish institutions. And so this could be a good place to start if you're trying to find a partner. So this is where you can download this tool. You can go to the Widening Impacts website and you scroll down, and there's a section called Consortia Building Tool. And you can download it from here. You can also scan this QR code. Shortly, I will paste this link into the chat, and you can also use this link. So thank you very much.
Thank you both for the presentations and the information provided. As reiterated, this program is in fact trying to make sure that different ecosystem actors are working together to find solutions to problems that are common and problems that may come about due to the use of the technology and the sector in itself. And the best way to collaborate and to work together is through project work or coming up with new work that would provide at least an incentive to work together in a longer period of time. And in order to make sure that several collaboration potentials are known and is available, we have Çağrı Yıldırım from TÜBİTAK, who will be mentioning of different calls and the different structuring of the Cluster 5 theme on energy to us today. So without further ado, dear Çağrı, the floor is yours, please.
Hello, everyone. So let me give me 1 minute to open my presentation. So I hope everyone is fine. Project introduction.
In the meantime, if there are any questions, please do refer the questions to the Q&A. We will have a dedicated section for question and answer, but if you do have any questions in the meantime, please feel free to write your comments in the appropriate section. Thank you so much.
Okay. Yes, I found it. Sorry, I have been doing lots of presentations nowadays, so that's why which presentation I have to do it. I need to choose it. So let me give the presentation is opening. I hope everyone is fine. So this is Çağrı Yıldırım. I am Horizon Europe National Coordinator of TÜBİTAK. TÜBİTAK is actually the core partner of the SolarHub consortium. Today in my presentation, when I open it, I am going to present it current cluster 5 call topics and also PRIMA program and the current Greek-Turkish bilateral call. Let me open it. Here you are. Share it. Okay.
We have a question in the meantime. Yes.
Okay.
Yes.
Can I start, Hande Hocam?
Yes,
okay.
yes, please go ahead. Please go
All
ahead.
good. Okay. Good afternoon, everyone. Here, my presentation outline. At first, I will give the information about the current TÜBİTAK Greek collaboration call, bilateral call. And then I will cover the Horizon Europe 2025 photovoltaic call topics. And I'm going to give information about the PRIMA program and Clean Energy Transition Partnership. So all of those calls are targeting the research and innovation, and they are the grant fundings, not the investment, not in investment funds, etc. Today I'm just going to cover the grant potential or existed grant mechanisms today. TÜBİTAK GSRI collaboration. TÜBİTAK is the national funding agency of Turkey. GSRI is the national funding of the Greece. So together they open a bilateral call, and this call aimed to intensify the cooperation between the Turkish and Greek participants in science and technology by means of the industry research academia cooperation projects. And the funding is intended to enable foundations to be laid for lasting R&D innovation partnerships. So the thematic fields under this call, so it's not a bottom-up call. Mainly the targeted or areas are decided by the two country funding agencies. The first area where you can submit a call, submit a project is bioscience, health, and pharmaceuticals. The project proposals need to focus on new medicines, exploitation of experimental and calculating approaches of rapid screening over specific macromolecular target and determination of structure-function relation. And it needs to focus on the advanced therapy medicinal products that are based in mRNA, genes, tissues, or cells. The second area is agri-food. The projects needs to focus on innovative technologies in agriculture and food, hygiene, quality assurance, improvement of process and treatments, accurate systems, advanced material technologies in agriculture, and food systems of integrated management of production and breeding. Protection of the natural resources of soil is another focused area under the agri-food. The third area, actually mainly relevant with the SolarHub, is the sustainable energy. The project proposals need to focus on materials and the requirements of the use and the solar energy conversion. Technology, systems, process for the energy efficiency and the energy performance of buildings, which in the area of recovery, exploitation of waste heat, cogeneration of electricity, heat pumps, renewable energy system applications, store energy, analytical tools for the increasing energy efficiency. So in the relevant topics are going to be supported by this call. Carbon capture storage and the transportation is another area for the technologies. And the solar thermal solution for the low temperature heat applications is the last area in this domain. The fourth domain is the materials, constructions, and industry. Advanced and or innovative composite materials for high performance, low environmental impact industrial uses. Advanced materials, methods, system-specific requirements, constructions, including transport, energy, civil protection, and infrastructure. Pilot applications in real-scale buildings or infrastructures to achieve synergies for the incorporating materials, methods, and or systems referred to in above priorities. Design, development, and production of the processes for polymers, biopolymers, bioplastics, biodegradable, specialty polymers for industrial and consumer products is the another area. So you can see the old domains areas. You can submit a proposal under the materials and construction industry. The fifth area is culture, tourism, and creative industry. Development of innovative methods, products, services, original devices to assess and respond to natural, technological, and man-made hazards that can threaten cultural heritage and to protect cultural heritage at the large scale. Circular economy is the last area for this call. What are the eligibility criteria? The maximum project duration for the project, maximum project duration is up to 2 years, 24 months. It's a prerequisite that proposals need to include participation from at least one Turkish academy partner, including public institutions or organizations, research institutions, universities, training or research hospitals, and Greek research institution or university, and plus at least one Turkish and one Greek SME. So the call basically is focusing on the academia and industry collaboration. Turkish and Greek-based teams must each be led by the lead principal investigator. So think about that. In the proposal, there are several partners from each country. You need to pick one principal of investigator from each country. So each proposal should have a project coordinator for the whole project who will be selected by the LPAs of the proposal. And this person will be responsible for the coordinating the whole consortium. Funding scope for each country has different funding scope. So TÜBİTAK funded cost of each grant shall be issued and managed by TÜBİTAK in accordance with the TÜBİTAK 1071 program. This is the international program. Actually, you can maybe you have experience in the co-funded partnership. You need to apply this program also as well. So TÜBİTAK funds up to 7 million Turkish lira per project. Turkish academia and public institution partners that are eligible funding can receive up to 3 million Turkish lira. Turkish small and medium-sized enterprises can receive 75% SMEs. Turkish large enterprises can receive up to 60%. Higher education institutions, their institutes, public R&D centers can receive 100%. As you might know, TÜBİTAK 1071 is eligible for all type of partner except NGOs. So NGOs or civil society organizations cannot apply to TÜBİTAK. But other than that, for example, municipalities or SMEs, large companies, universities can apply to the TÜBİTAK. So they can benefit from this program. GSRI will contribute 3 million euros to the funding measure. So each project can receive up to 200,000 euro per project. So in the end, actually, we can see up to 15 projects is going to be supported by this call. Call deadline is 22nd September. So I just shared the call work program is here. So I see this SolarHub community and the other widening communities are very good community area to increase the cooperation for this specific call program. In the SolarHub, 3 years ago, we started almost. So we have been working on to establish this call collaboration, and we are successful. And I hope to see this call will result very good. This call will bring lots of good project cooperations between the Turkey and Greece. So if you have any questions, please let me know for later on, so I can give some more details about this call. Let me move to the Horizon Europe. So I mentioned about the bilateral call. Now I am talking about the Horizon Europe program. Turkey is the associated country in the program. Greece is the member state, is originally, naturally is a part of the Horizon Europe program. So, but both countries are fully eligible for this program. I can say it. So, the SolarHub is funded under the Horizon Europe in the end. But today, since we are focusing on more in the photovoltaics and solar area, I am going to give some information about the open calls under the Horizon Europe Cluster 5, where the energy thematics are supported. So we have the call has been published at the end of the May, but the call has been opened since 6th of the May, and 2 September is the deadline. We have two calls. One is I am going to give the details about those calls now. The first call is about the optimized alternative silicon growth technologies for PV applications. The call has a deadline for 2 September. The type of the action is innovation action. Actually, it's a high TRL level, 7th or 8th. At the end of the project needs to be completed. The proposal or the project need to be completed 7 or 8 at the level. Budget per project is 9 million euro. And in the end, two projects is going to be supported by the commission. The aim to facilitate and continued and rapid proliferation of silicon photovoltaics, realizing new and more efficient and less energy material intensive process for silicon feedstock, ingots, and the wafers needed. Proposals are expected to address at least one of the following challenges. So there are two challenges. So each consortium or each project needs to select one, either demonstrate the alternative efficient and scalable process or methods, equipment to grow silicon ingots and the wafers from the either liquid or gaseous phase at the lower cost and high quality compared to standard process and possibly avoid the wafering step. The second one, optimize standard processes and equipment for detect impurities and structure loss minimization, high quality ingots with large diameters. So this is important. The consortium needs to involve at least one silicon ingot or wafer manufacturer. The call program has been supported by the Horizon Europe, European Partnership for Innovation in Photovoltaics co-program partnership. So this partnership is established last year. Now they started to give support for the open the calls for this photovoltaic area. You can reach the call details on the funding and tender portal. The second call is again the innovation action. It is called as novel inverter technologies and flexibilities in PV systems. So the call project, the budget for the per project is 6 million euro. In the end, 3 projects is going to be supported. Proposals are expected to at 6 of the domains. So when you write the proposal, you have to answer these 6 thematic areas. Demonstrate the new inverter technologies with increased power density and reliability at lower cost. Design of smart and with improved capabilities inverter hardware and firmware. Ensure inverters electromagnetic capability proposing optimal mitigation techniques. Use of control and power hardware in the loop technologies to determine interactions between the multiple inverters. Demonstrate integrated communication between the connection between the inverters and other components, and evaluate the system integration and cyber security. Again, this call is originated by the European Partnership for Innovation in Photovoltaics, and the call details are available in funding and tender portal. So when it's a innovation action, it's actually demonstration activities are supported. So high TRR number. So in the end, the existing technologies need to be shown is applicable in the in the real area. So that's why the demonstrators are very important in these coal projects. And the coal consortiums are expected to be a bit higher number of the partners. Let me go to the another coal topics, but this destination is another coal deadline. So now I'm talking about the call opening date, 16th of September 2025. The call is not opened yet. It will be opened on 16th of September. Let me give the details about those calls. The first call is towards commercialization of perovskite PV and the development of dedicated manufacturing equipment. Again, this call is the innovation action domain. The call budget is 24 million euro. For each project, 8 million euro is dedicated. So in the end, 3 projects is going to be supported. So the call deadline, sorry, I write it wrongly, is 17th February 2026, not 2027. Proposals are expected to address all the following aspects: demonstrate effective strategies to enhance the optoelectronic properties, performance, and stability, scale up reliable deposition of high-quality perovskite films, demonstrate internal and external encapsulation and the structures as protection from the extrinsic environmental stressors such as moisture, oxygen, heat, illumination, assess performance and reliability according to the international standards and compared with the well-established PV technologies, demonstrates suitable equipment adapted to specific requirements of perovskite production processes. Target groups, each consortium needs to involve at least one perovskite or equipment manufacturer. Again, the call is supported under the EU PV partnership. Let me go to the last call. This is the one, research and innovation action. TRL number is lesser. Let me go to 4 or 5 in the end of the project. So in here, the name of the call, extending the lifetime of crystalline silicon PV modules. So the scope is to tackle the issues, material properties, environmental stress, installation, etc., and extend the lifetime PV modules. The project proposals are expected to demonstrate effective strategies to enhance the optoelectronic properties, develop where necessary simple, cost-effective, and accurate model defect detection techniques, propose mitigation approaches at module and system level, and perform outdoor field experiments and testing to determine degradation rates. The call is written, different locations representing in the European range of climates are to be considered. Where it means that at least, the project needs to show the Mediterranean area impact, for example, or the northern phase of the European level. So there needs to be different partners applications in this consortium. Different climate approaches need to be shown. So that's why the consortium can be composed of the different country organizations where there is a different climates actually in the end. So those are the Horizon Europe calls. Under the Horizon Europe, there are some partnerships. Those partnerships are dedicated in different areas. One of them is PRIMA. PRIMA is the European Partnership for Innovation in Mediterranean region, where it aims to support the advancing the research sustainability. It's a strategic EU partnership. There are 20 participating states, including the Turkey, Greece, and all the Mediterranean countries, almost all the Mediterranean countries, I can say. But there is also Germany, Luxembourg, and France as well. So France is a Mediterranean country, but Germany, Luxembourg, and are also the part of this network. Program thematic focuses is PRIMA is unique research and innovation instrument in the Mediterranean to break conventional silos to address the water, energy, food ecosystem nexus. So there are 4 areas where you can submit a project. Water management is one domain. Farming systems is second domain. Agri-food and value chain third domain. And then welfare nexus is actually a cross-cutting area where water, energy, food, and ecosystem can be supported. So in 2025, Section 2 is open now. Section 1 is already completed. Under the Section 2, there are 3 core topics. One is enhancing policy development through impact-driven water footprint and virtual water concepts in the Mediterranean. The second one, upscaling agroecology practices at the farm level in the Mediterranean. And the third one, towards a plant-based alternative protein products transition in the Mediterranean region. Consortium structure at least 3 independent entities from 3 different eligible countries. One from the EU member state associated country, one from the Mediterranean partner country. Call deadline is 8th of July. You can go into the Prima website and you can see the all call details in the info there. It's listed still and you can watch it now. So this call is very interesting, and Turkish and the Greek applicants are very high. There are very high application from both countries as well, I can say it. The other partnership is Clean Energy Transition Partnership. This is the partnership actually basically focus on the energy challenges. There are 10 different transition initiatives, which means that 10 different topics are identified for each call. Turkey and again Greece and almost most of the Western European countries are part of this partnership. There is also India and Canada in several of the call domains. You can see the call. There are 10 call modules. For example, if you would like to submit a proposal for the solar area, you can submit a proposal to energy system flexibility, renewable production, storage, and system integration, which is the second TRI area. But other than that, you can see heating and cooling technologies, hydrogen, renewable fuels are supported under this domain. The call is opened for the pre-proposal submission. So it has a deadline for the 9th of the October. So this is the call is another area. Actually, what I can tell you that this Clean Energy Transition Partnership and Prima is alternative for the Horizon Europe calls, because Horizon Europe cluster calls are very competitive and very small number of projects are supported. But under these domains, under these alternative programs, success rate is a bit higher. So if you have any question for these partnerships as well, please do not hesitate to contact with me. And thank you very much. That's all for the all existed programs in the domain of the photovoltaics and the solar PV areas, I can say. Thank you.
Dear Shari, thank you so much. We have several questions from Mr. Bektaş, which are quite relevant to what you have talked about. The first question might be the following. Currently, how many projects will TÜBİTAK be supporting under the Prima call at the moment? Do you have any numbers in regard to that?
Until now, under the Prima, how many projects are supported by the Prima calls? This is the question. Yes. Until now, since 2021.
No. In regard to this call, the upcoming call, I mean, what is the target number?
Target numbers. I think I need to check it, but the TÜBİTAK budget needs to be first. I need to look at the TÜBİTAK budget for this call. I can send you. I can give this detail later on by email. I need to note it. I need to make sure if there is a specific call budget for the Prima by the TÜBİTAK, I can answer it very clearly.
We have other questions. Maybe it could also be reflected, but to give some insight, he has mentioned, especially if there is going to be an installation, usually in the Turkish law, we have what is called the etki değerlendirme rapor, or the environmental impact assessment report, that is required by law. But when it is under a certain European call, are the entities entities exempt from this, or how is this processed, especially in regard to getting this document? This was also asked. And another question in this regard is what are the role of municipalities? Maybe it would be good if you can also mention why it's important that different entities collaborate together. And I think Mr. Bektaş is especially wondering about the municipality and his role there. Can you give some insight into these two questions, please? Thank you.
I think thank you very much for the questions. For the municipalities, what I can say that municipalities can be involved in the both in the three of the programs. For the TÜBİTAK GSRI call, municipalities can be involved as a maybe sometimes most of the case municipalities are involved in the consortiums as a demo partner application sites, for example, I can say. So they have a very big role, especially in order to show the impact of the project. So especially in the Horizon Europe, already the municipalities are involved a lot. But in the under the 1071 projects, TÜBİTAK is supporting as well the municipalities at the 100% cost level. So it covers most of all the costs, I can say. So there is no any bottleneck regarding to involvement of the municipalities. Well, what was the second question, Hande Hocam? I just missed it.
In regard to the ÇED report, the Çevre Etki Değerlendirmesi, or the Environment Impact Assessment report, normally this is mandatory for all installations within Turkey, but when it is under a certain, let's say, European Union, let's say, project,
Yes.
do the entities still need to get this ÇED report?
Yes, definitely. So for the European Union projects, if there is a demonstration sites, if this, for example, agrophotovoltaics application is going to be applied, there should be some ÇED report to make eligible to install this, all the necessary equipment, etc. So this is a kind of requirement to have the sustainability of the project. So it's a necessary.
Okay. Maybe in regard to when it is needed, could be part of the project structure. But again, we follow the European Union rules, but we also have to be in alignment with our Turkish law and as well.
So what the European Commission is saying that, Hande Hocam, let me clarify that. For example, European Commission is accepted to, first of all, they are saying that all the regulations should be compiled with the national regulations. For example, when we give the mandates or the person month costs, the Commission is saying that it should be compiled with the Turkish regulations. So you cannot define any rules which is conflicting with the national regulations. So the Commission is, first of all, look at the national regulations of each country. So then it's okay for them. So that definitely, first of all, they should comply with the national regulations, like I say it.
Again, it is also relevant for other like financial reporting and other requirements as well. So, dear Tar, thank you so much for the informative presentation. We can be taking on questions at the end, but at the moment, or if you have any questions as was referenced, we can also share the email that you had shared previously. So if there are any further questions, they can contact you directly, if that's okay.
I will contact with the Bektaş Türe. So I got the email address on the chat section. So thank you very much for his good questions. So I will communicate with him. If there is any other questions, let me know that. Thank you.
Thank you so much again. Now, as was reiterated, we want to be integrating all of our entities together and to understand the potential of collaborating. Where do we collaborate? Do we collaborate on an already given problem in a certain, let's say, project scope? These are main questions that need to be handled. And what we are going to do now is to go to our third session in regard to presentation of our industrial challenges. How are these challenges? How have these challenges been derived? Especially our task leaders within the SolarHub project, as well as our industry partners, have come together to assess several key challenges that could be addressed to support the solar energy ecosystem, as well as support collaboration potential that could come up. What the aim here is to have an idea of the problem itself, and as an entity, if you would like to collaborate in trying to solve this within with a new project to work together, or with a new, let's say, model that you have that would be supportive of this, we encourage all of the match making to come from this. So what we will do is we will be presenting several challenges pertaining to both PV and solar thermal. And accordingly, if you have any questions or if you'd like to be matched with such a challenge, please feel free to write any details that we can contact you for further, let's say, collaboration or assessment. So without further ado, I'd like to invite to the floor from Kalyon PV, Ramona Davut Saad, in regard to mention of stock and material management problems within the PV industry. Dear Ramona, are you?
Yes,
Yes.
thank you, Hande.
So, yes, please go ahead. So we will first start with a PV-related industry problem that will be presented by our industry partner, Kalyon PV. So, dear Ramona, the floor is yours, please.
Thank you. So, hello everyone. My name is Ramona Davudnesat Apaydan from Kalyon PV. Today, I'd like to share a challenge we're addressing as a vertically integrated solar manufacturer, which connects both material sustainability and digital stock management, which are two core pillars of this call. Our initiative called is Waste to Value, and it focuses on transforming overlooked industrial byproducts into functional materials for clean energy systems. I think I can make it. What happened? Sorry. So this slide shows the standard production flow for silicon-based solar models, starting from sand and ending with fully assembled panels, as you can see from the figure. Along this chain, a significant amount of material is lost, particularly during the wafer slicing, where up to 40% of the silicon becomes carved. So we also generate glass waste and aluminum scraps in other steps to produce our final panel. There are not just environmental burdens, and they represent untracked stocks in our factory, which missed value in our current manufacturing row. So right now, these waste materials are collected, but there is no internal valorizations and no material traceability. And at the best, they are exported or sent to our landfill, which add cost and emissions. So if we can find some solution for this problems, here are some of our aspects that will be solved by finding some solutions for this problem. For example, from the excess stock of this scarf, we have lots of waste stocks which we can deal it with it. As a circular stock flow, we need actually make this scarf, for example, recycled into functional materials to make it again, put it again into our internal supply chain and use it, or maybe just sell it to other companies. From another aspect is the cost and footprints. So if we get rid of our kerf waste or decrease the amount of it, of course, the cost of our panels will reduce too. And the other problem is we don't have a good digital stock monitoring of this waste. So if we can get some solutions for this problem, maybe it will be easy to find way to make functional materials from these wastes. And the last one is the strategic raw material substitution for this, where by converting industrial waste into usable materials, we can have dependency on virgin materials, which is a stock vulnerability in the clean energy sector. So I have some problem with my slides. So technologically, our valorization process are between TLR 4 and 5, meaning they've been validated at some lab scales. And but when we comes to systematic tracking our waste stock, we are at TRL 2, 3. We don't have any digital system yet that links our byproducts flows to internal reuse waste. And that's why we aim to change through this collaboration with both material scientists and digital tool developers. If we have a collaboration with things that it reduced our landfill production waste by an amount of 50%, and our material cost will be decreased about 50% by reintegrating this valorized byproducts. And it would be also lead to measurable CO2 reductions, both for avoiding transport and substitution of virgin materials. Our goal is to demonstrate this with a TRL-6 pilot system, a digital inventory tool paired with lab scale materials reused at our manufacturing site. So now we are actively looking for partners to bring this idea to this Horizon and Cluster 5 call. So we need some collaborators in 3 different areas like digital stock training, trackings, material, some demonstration of circular flow at PV manufacturing sites, or maybe engage some recycling and waste treatment companies to upcycle our materials. Thank you for your listening. So if any, I think we do the question part at the end of the session.
Yes, indeed. If you have any further questions, please feel free to write in the Q&A, where we will have our experts to answer your questions or to have any matches with the problem as well as the scope of work that you do. So thank you, dear Ramona. After Ramona, we have Onur Taylan from ODTÜ Günam, who will be presenting 2 challenges. The first of which is the integration and control of solar heat with HTL, and digital twin for solar biorefinery. Dear Onur Hocam, the floor is yours, please. Thank you.
Okay, thank you, Hande Hocam. I hope you can hear me and see my screen.
Yes, we can. Loud and clear.
Thank you. Good afternoon, everyone. My name is Onur Taylan. Let me introduce myself. I'm an associate professor in the Department of Mechanical Engineering at Middle East Technical University in Ankara, Turkey. Also, I'm coordinating the Concentrated Solar Thermal Division at ODTÜ Günam, which is the Center for Solar Energy Research and Applications. So, as Hande Hocam mentioned, I'm going to introduce 2 challenges regarding our pre-design in SolarHub Test 3.2, which is focusing on advancing solar-aided hydrothermalification process for agricultural and livestock residues into valuable products such as bio-oil. So I will be very brief so that if you have any questions, I can answer them later on. And especially if you are interested, feel free to reach me out so that I can give more details. So this is the concept of our task pre-design under the frame of SolarHub project. This pre-design addresses, as I said, solar-aided hydrothermal or high-pressure processing of agri-food wastes or byproducts that turns into something valuable. So the name of the task also includes valorization of the waste. So our targeted products include bio-oil and potential other useful products, depending on the waste feedstock. It can be nutrients, it can be gaseous fuel, depending on the feedstock, as I mentioned. So under this one, we have three major pillars. The first one is the hydrothermal liquefaction part, which is abbreviated as HTL. This is handled by CERT. By the way, this task is also co-led by CERT. It is led by Günam, co-led by CERT. And under the experimental setup, we are trying to reach the technology readiness level of 5 to 6. And then the second pillar is the thermal energy storage part, which is what Günam is handling and designing over here. And the third one is the parabolic trough collector, which is the concentrated solar thermal collector over there. Briefly, let me talk about how this works. Yeah, so in this part, we are feeding the feedstock over there, as you can see. And this process requires high pressure, also moderately medium level temperatures over there. So I will give more details in the upcoming slide. And then by having this chemical physical process, thermal process, we are producing the products, as I mentioned. So this reactor requires energy, obviously, and this energy is coming from the concentrated solar thermal. Conventionally, electrical heaters are used for this reaction, but one of the novel parts of this pre-design is to switch from the conventional electrically heated autoclave type of reactors into solar-aided reactors, as in this schematic over there. So this blue part is nothing but the mirror, which we refer as the parabolic trough collector. So in the focal line of the parabolic trough collector, we put this reactor to have the reaction happening over there. So this is solar energy is the source of that energy. And since this reactor requires some sort of like stable energy need, and solar energy is variable in its nature, we are complementing this with the thermal energy storage part over here. So when the solar energy is not enough, or maybe during the nighttime, to give the nighttime provision or the low irradiation provision to the reactor over there, we are backing the reactor with the thermal energy storage. So we are also designing this thermal energy storage. And one question is to have the sizing problem between those two. During the day, we have the second parabolic trough collector, PTC collector over here, so that we are using this we are using this collector to charge the thermal energy storage over there. Okay, so this loop is basically that we utilize during the day to charge the thermal energy storage. Typically, we run some synthetic heat transfer fluid, like synthetic oil, that we run through that one. So as it runs through this collector, it heats up. Its temperature goes up to 350, 400 degrees Celsius, whatever it can go. And then we store this in this packed bed thermal energy storage system. And in this packed bed thermal energy storage system, instead of like storing the liquid by itself, it's in high pressure or high temperature, we prefer to store it in the solid kind of pellets or solid particles, so that it also has higher heat capacities in a general sense. And during night time, this part basically does not run. So we take the heat transfer fluid, synthetic oil from the thermal energy storage, which is hot, and then we run this through the HDL reactor, and then this outer loop is basically followed. Again, at the nighttime or when the energy is not enough. So this is basically our idea. So feedstock is the waste, and we are trying to valorize it and turn that into something useful. Typically like bio oil, but it can be some fertilizers, it can be gaseous fuel as well. So this is the basic introduction of our task and what we are trying to do in our pre-design under the task. So Hande also mentioned that one. So we have two challenges regarding this task. The first one is integration and control of intermittent solar heat with hydrothermal liquefaction processing. That is the reaction over there. So this pre-design targets or outputs bio-oil as the primary product, as I mentioned. And this HDR reactor requires stable operating conditions. So I mentioned here, just to give some idea, obviously this depends on the feedstock. The general sense is higher is the better in this sense, but for these kind of particular applications, we are trying to reach continuous temperature around 300 to 350 degrees Celsius and pressures around 200 to 300 bars over here for several continuous hours. And however, as I said, solar energy fluctuates with the cloud cover or during nighttime, it's not present. So this introduces significant complexity in our stability and efficiency. Therefore, what we need is a robust and intelligent thermal control system. Obviously, it should be able to handle real-time coordination between these three pillars that I mentioned, the HDR reactor, the parabolic trough collector, and thermal energy storage. So by turning the valves on and off, so it should have the intelligent control system. So it should be, this challenge introduces developing predictive algorithms based on the meteorological conditions, obviously, automated valve controls and energy prioritization strategies. So when we need to decide when to store the energy, when to divert that into the HDL or deploy the stored heat into the HDL, so on and so forth. So overall, our goal is to maximize the solar utilization, minimizing the cost, minimizing the fossil fuel backup or the electricity backup for this HDL reactor, so that we can greatly enhance the operational as well as the economic feasibility of this solar-aided HDL systems in general. So this was the first challenge in a nutshell. The second challenge is more regarding the digitalization and optimization of the entire ecosystem, biorefinery ecosystem. So the title is digitalization and optimization of multi-component solar biorefinery systems. This requires modeling of those three pillars as well. So this SolarHub concept, our task concept, involves multiple interconnected systems. Once again, just to remind you, the parabolic trough collectors as the concentrated solar thermal systems, the thermal energy storage units, and the HDL reactors, hydrothermal liquefaction reactors, as well as the feedstock processing. So scaling these systems up is a problem. So we have the we have the technology readiness level of 5 to 6 at the end of the project. So these are mainly something like lab scale or pilot scale systems. So we have these three components in our labs basically, but we need to also determine like how these systems will react in terms of when we scale these components up. So this also proposes another challenge, challenge different than the first one. Scaling these systems up to the industrial level is kind of like hampered by the lack of integrated digital tools, because we need some special digital tools to integrate these three devices up so that we can simulate and optimize the operations when needed. So this is also something that we also need when we approach to a customer. So when we approach to a customer, we need to also do some like tailored solutions to them. So what's their feedstock, and then what should be their yield, what like solar or meteorological conditions they have. So these things will also be variable. So here in this challenge, our objective is to develop a modular digital twin that can also be coupled with ML, machine learning, that can accurately model the thermodynamic behavior of our systems, the flow dynamics of our systems, and process integration. Especially, we are interested in the process integration of this one. So in our team, we have mechanical engineers, we have chemical engineers. So we know the basics, but we need some sort of like interface and all these like digital tools so that we can reflect what we have in our mind to the outer world, I should say. So we are exploring the integration of the sensors, the maybe IoT networks, or the cloud-based analytics. So for the predictive maintenance, the energy yield forecasting, the feedstock yield forecasting as well, and maybe even the lifestyle optimization, life cycle optimization. Because one thing that we are also doing in these tasks, in all the four tasks under the SolarHub project, is we are also assessing the life cycle of our system, also like the economic analysis to a certain extent that we do. So we would like to adapt our system for basic or for different needs, different maybe customers. So the system, the digital tool system must be flexible enough to accommodate different types of feedstocks. So we are focusing on the fruit waste, but it can also be like the livestock or any kind of other food waste. So without obviously, without such digital infrastructure, we are kind of limited ourselves into our limited feedstock. So we are also kind of need some sort of a stepping stone for upscaling our systems. So this is the second challenge that I would like to mention. And with that, that concludes my presentation. Thank you for your attention and time.
Thank you very much, Onur Hocam, for the detailed information on the two main challenges. I would kindly request our presenters to also mention any email or contact information. If any of our attendees are interested, that would also be a good match as well. So thank you again for the great challenges and the great potential ahead. Our next presentation is in regard to the PV industry, and we will have a presentation by Evangelos Rikos from CRES. The first challenge is a joint challenge that was mentioned from both CRES and Bright Solar. The challenge in itself is tools to come up with a tool for optimal PV model transparency, and we're curious to learn about that. So the floor is yours, dear Evangelos.
Thank you, Hande. Exactly, one of the challenges regarding this pre-design is how one can select the optimal transparency of the PV modules and the structure itself with the use of a digital tool, preferably, which is supposed to give more systematic and accurate results. Without further ado, first of all, I would like to briefly mention the problem in a nutshell. Agrivoltaics is an approach that has been adopted recently in order to tackle issues of land scarcity for the installation of photovoltaic systems. And in addition to this, the tendency to substitute farming areas in order to install photovoltaic power plants is not, let's say, a very favorable choice. So researchers have started studying this alternative as a combination of the two, because agrivoltaics focus on the dual use of land, energy production plus the crop production. However, the use of agrivoltaics have some, let's say, consequences. For example, if we consider a photovoltaic structure above a crop, one thing that certainly happens is that we have an amount of shadow that the photovoltaic panels cast on the plants. And as the sun position changes over time during the day and during the year, the shadow changes. There is a path, let's say, that is followed, and some areas of the field below are shaded more than others. In any case, the important thing about this effect is that plants receive a rather lower irradiation, which may result in a lower photosynthesis rate. The parameter that is usually used here in order to express this behavior for plants is the photosynthetically active radiation, and how this affects the photosynthesis is pretty much summarized in a generic diagram on the left, which shows that for lower levels of light, the photosynthesis rate increases rather linearly. There is an area of saturation where the photosynthesis reaches its maximum, and beyond that, if the light is more intense than necessary, then the plants cannot even reduce their photosynthesis rate. This is the photoinhibition region. Based on actual experimental data, we can see that with the use of photovoltaic panels above specific types of crops, like in strawberries for this case, on the right-hand side diagram, we see that excessive shading can result in a reduction in the crop yield, which is something that we generally don't desire. So, in order to tackle this issue, and what we have proposed in our pre-design is the use of semi-transparent PV modules. So we avoid the use of standard type PV modules. We use modules that have a smaller number of PV cells, and transparent glass that allows most of the light to go through the panels and to the plants. In order to get some good, let's say, design, we have also proposed a methodology which, despite the fact that leads to some good results, it doesn't give the optimal results. It gives just an estimation of how, if there is a detrimental impact effect on the plants due to the use of the photovoltaic panels, but it doesn't give the optimal transparency level that would allow the maximization of the energy yield and the crop at the same time. On the right-hand side diagram, we see an example of the proposed PV modules in our analysis. So in order to take this analysis a step further, the challenge here that we foresee, is that we do not have a systematic approach and or tool that would automatically give the optimal transparency calculation for the PV modules based on specific parameters, and that would that ought to cover a wider range of cases in order to ensure also the replicability of the solutions. The solution should be applicable to nearly any kind of crops, not just the crops that we study in our project. As a minimum set of specifications, we are talking about a software tool which can calculate and provide as a result the transparency of the PV modules based on some inputs, including geographical location, the climate zone, the type of crops, and some geometrical characteristics that we're going to consider for the supporting structure of the agri-PV. As a current approach, we should mention that we have already come up with a calculation for the shading effect for a given transparency, but this does not give us the optimal transparency. And we are aware of existing studies that relay the specific issue, that address the issue of optimal transparency calculation for specific crops. As a state-of-the-art approach, however, we should potentially include in this challenge, in this tool, an AI-based platform that uses online data related to different types of crops, location, structures, and weather forecasts, and can also access specific references and relevant studies. And this summarizes the first, so I think I can move on to the second challenge, right?
Yes, please
Okay.
do, dear Evangelos.
Good. So, yeah. Again, here, this is related to agri-PVs, even though the power system integration and the quality issues that emerge from the mass penetration of agrivoltaics is not much different to classic, to standard photovoltaics and other renewable energy sources applications, so to speak. But maybe agri-PVs have some more particularities in terms of the areas, the installation areas. We're talking mostly about the rural networks where areas are equipped with rather big electricity grids, and this may intensify the problem to some extent. Here is an overview of the problem. Imagine that we have a distribution transformer, medium to low voltage distribution transformer, and a distribution line that at the end of it we have a photovoltaic system connected to, and there is also another feeder that supplies local loads. What happens here is that even though at the output of the transformer, the voltage could remain within the acceptable operating limits, it's rather hard to maintain both B and C voltages within the operating limits, which typically are plus 15 and minus 20% of the nominal voltage of the grid. And this is because of the high amount of power that the photovoltaic generator could inject into the grid. One obvious solution to that problem would be to connect some consumers at the point of common coupling of the PV generator in order to consume locally the electricity produced and reduce then the power injected to the grid, which result in reducing the in reduction in the voltage variations here. However, there is a second problem here with that, the mismatch between the power generated by the photovoltaic and the power consumed by the load may not be the same. Of course, this means that only a part of the produced electricity is consumed locally, and the rest of it should either be stored and reused at a different time by the load with the use of batteries, for example, or the load itself could be shifted in order to match the photovoltaic production. This is what we call the flexible loads and the use of flexibilities. So one architecture, because there are many ways for one to do that. One architecture that is the, let's say, most promising one, the most complete, let's say, approach is microgrids. It's a group of interconnected loads and distributed energy resources which have specific boundaries and act as a single controllable entity, and they can operate in grid connected or islanded mode. They usually refer to small scale low voltage power systems with a point of common coupling at the distribution transformer I showed earlier. Their purpose is primarily the use of household communities, rural communities, as in our case, and the mixed suburban environments, with other applications as well being valid. And they incorporate three different types of resources. We have the micro sources, the generators, in other words, micro turbines, field photovoltaics, etc., storage devices, including flywheels, energy capacitors, and batteries, and controllable loads. As I mentioned before, it's a very important part of the microgrid, which also incorporates some very specific hierarchical control divided into different levels. Level 1 addresses the local devices. Level 2 is the central controller at the microgrid level, which coordinates the controllers of the local devices. And there is also interaction with a level 3 controller. It's part of the distribution management system of the DSO, as a matter of fact, not within the microgrid, but it's still an important entity. And the quantities that we want to control with this approach is voltage and frequency, especially for islanded mode, and of course coordinated voltage and frequency control. The control of these two quantities happens either locally or in a coordinated manner, and the energy management is a secondary but also very important control goal that happens in both grid connected and islanded mode. And yes, here we have a summary of the challenge and what we expect out of it, the support that we can have by involved third parties. First of all, we want to analyze the impact of massive integration of agri-PVs, as this has not been investigated in our project, and specifically the impact that they have in weak distribution grades in rural areas. Of course, here the minimum specification involve methodologies, technology solutions, including power units or control systems, and software tools in order to facilitate the design and integration of agri-PVs in the distribution system. Currently, there is extensive knowledge in the area of microgrids as generic use structures that allow higher RES penetration with the help of storage flexibilities and control in order to optimize the balance. And as a state-of-the-art approach here, we could consider specific particularities that are related exclusively to the use of agri-PVs or the potential issues of using battery storage in this environment, and other possibilities like energy sector coupling for this type of application specifically, and what type of flexibilities one can have. This concludes my second and last challenge. Thank you.
Thank you so much, dear Evangelos. You have touched upon two important implications in regard to land usage as well as grid management, which is quite important, and especially as we had a recent outage in Spain and Europe, it has become important how we integrate and what is important and prioritized in such use of renewable energy mix within our energy supply. So thank you so much for the insight. Dear all, we will be continuing with our next challenge in regard to smart control for industrial solar thermal. This challenge was developed by Kress and Samler, and it will be presented by SolarHeat Europe, which is a very important entity, especially for the solar thermal sector. Dear Lucia Torlaia will be presenting on this problem's behalf. So without further ado, dear Lucia, the floor is yours, please.
Hi, good morning, everyone. I hope you can see my screen correctly.
Yes, we can.
Okay. Thank you. I'm Lucia Torlai from SolarHeat Europe. We represent the solar thermal industry at the European level in Brussels, and we're part of the Athens ecosystem within the SolarHub project. Today, I'm going to present the challenge on the smart control for industrial solar thermal, because this is the challenge that SolarHeat Europe is involved in within the project. My brief presentation will first introduce why is smart control important in the solar thermal sector and industrial applications in particular. Then I will briefly explain what are we doing in the SolarHub, especially in task 3.1, where SolarHeat Europe, Kress, and Samler are improving an innovative smart controller for industrial solar thermal within the project, and what are the future steps finally. So what we need for future collaboration on smart control also within this context of matchmaking session that we're having today. I apologize in advance if my technical knowledge of some of the things I will talk about is not very high, because I'm in the industry since just a couple of months, but okay. So as you know, smart control integration is the fundamental for industrial solar thermal system, mainly because of optimization of energy efficiency, reduced energy consumptions, and increased reliability. So first of all, why do we need smart control integration? Because we can measure more effectively and more tangibly the energy savings, so the benefits for the end users. So this can have a very strong impact on the market. It can be a market boost for solar technology, especially we know that in Greece, the solar thermal production is really advanced. So showing customers the energy efficiency savings in a tangible way is fundamental, thanks to a smart control. And connected to this, of course, with the smart control, we can increase the comparability between the solar thermal and other technology and show how much it is efficient in transforming the solar energy into heat. Thirdly, of course, the solar smart control, AI-powered smart control, can increase the real-time monitoring and control performance, because the sensors and the control algorithms can monitor the system performance in real time, including all the different parameters like temperature, pressure, radiance, and allow different adjustments. So allowing also for an optimized system operation in real time, maximizing energy capture, minimizing losses, and ensuring a consistent thermal output of the whole system. And finally, a smart control integrating in solar thermal can better allow for the integration between solar thermal and other systems, such as heat pumps, but also the other renewable energy sources, enabling a more comprehensive energy management overall in the industrial site. So what are we doing in SolarHub concerning this? As I said, Solar Heat Europe is cooperating in task 3.1, that is developing a pre-design of solar thermal solution for low temperature heat applications. And one part of this task is the integration of this smart system control for energy efficient management that would be specialized in agro-food and industrial applications. We are cooperating with Cress and also Samler, the producer in Greece. And this smart control for energy efficiency management will provide realistic data for the system implementation in a holistic view. We are developing this through a project under the Solar Certification Fund, SCF, called AI integration. So the innovation of the smart control in the SolarHub pre-design that we're talking about is the integration of an AI to monitor the parameters specifically for this industrial application. And we're being helped by the University of Stuttgart Institute for Building Energetics, Thermotechnology and Energy Storage, IGTE, who is developing a comprehensive study on smart control system, which is quite advanced. And despite some initial delays, this project on AI integration is now on track. And this project will deliver a full implementation of the AI control approach into solar thermal system simulations within some months. The reference systems have already been built. So there is this study on smart control system that includes a detailed methodology, a comparative analysis of all the existing study on smart control. So what is the state of the art and how we can innovate compared to the state of the art. The reference system has been built for this AI integration, and it's now working on the parameters. So the different parameters such as the load, the size of the collectors field, and other control parameters. And the definition of the type of AI control is ongoing and will be implemented soon as the parameterizing goes along. Here we can see the key findings. For example, the reference system, as I said, has been built using the dairy industry as an example system, using Transys with the different parameters. And the first results are available. I won't go into this now. And the constant load profiles are being used for the moment, but then it will be applied to the agro-food and and different industrial settings as per SolarHub grant agreement. Then also we have these first results of the simulation and the high potential for the control optimization that is there, which will give a definition of the control approach by July 2025. So it's really ongoing now. And it will also apply this to different climatic conditions. So one of the points in this project is to apply this AI control approach in the smart controller for solar thermal to different climatic conditions and see if there are any differences. So the next step is the finalization of the study by the end of the year, the AI integration using ANN that is ongoing, and the implementation of the AI control approach into the solar thermal system simulation will be finalized by September 2025. So for the future, we are here for also finding future partnership, future collaboration with solution providers such as startup, as you said in the introduction. So as SolarHeat Europe, Samler, and CRES, we have strong manufacturing in Greece already working on this, of course, Samler and others. And also there are past projects developed by Greek institutions such as EBHE on smart controls, of course. And also we have the technical knowledge. So not only this study on AI integration in control that will be by the end of 2025, as I said, but also other previous studies. So the technical knowledge on the smart controls and the benefits of it is definitely well developed and is ongoing as well. So how we can innovate further is to basically collaborate with other companies, startups specialized in control in Greece, Turkey, or other countries to basically make marketable solutions. So not only like a study or a technical idea, but really to provide marketable solutions in the next few years, and the future partnership to further develop the technicalities of the smart control for solar thermal and the applications to different industries. So the dairy industry, the agro-food in general, but also other industries. And of course, we are always open to different ideas. And if you have any potential avenues for collaboration, don't hesitate to reach out to us. This was my presentation. And if you have any questions, you can leave them in the chat. Thank you.
Dear Lucia, thank you so much. As was mentioned in the last title that you have, marketable solutions are indeed important. And as much as developing the technology is critical, it's also important to enhance and be aware of the technology adoption. That is also a problem that needs to be looked out for. And in this regard, we will have dear Marisol Orpeza mentioning about this problem in regards to market entry of Greek large-scale collectors. She has experience in several continents, and with her energy, we're looking forward to understanding the dynamics of how better we can adapt as well as integrate for better market entry. So without further ado, dear Marisol, the floor is yours, please.
Thank you, Hamde. Thank you, everyone. Please confirm if you can see my presentation. It's written task 3.1.
Yes,
perfect.
Thank you.
Perfect. So I'm very glad to be part of this project, and I will be working together with Samler, the company from Greece, and CRES regarding the solar thermal collector part of this task. So first, I'd like to give you some introduction about what has been done as part of this pilot. And for further technical details, you can reach out to my technical colleagues. So first, the progress that was there by the end of last year was the first prototype was built at Samler factory. Samler is a company manufacturing solar thermal collectors and exporting large part of the production. So in cooperation with CRES, they are building this new collector for low temperature solar thermal industrial applications. That means everything below 120 degrees Celsius. And for this, also the sensors and the monitoring system were developed and installed. Also, there were some improvements in terms of the construction, which will make the maintenance and installation much easier, which is key in this type of projects because it affects a lot of the cost part. Also, there have been a lot of activities since March 25, such as collaboration with heat changers. I will tell you a bit more about that in a couple of minutes. Also, study tour, common synergies with the Hellenic Institute of Passive Buildings. A summer school will be organized, also practical trainings and diploma thesis. So this is all part of the cross synergy and cross collaboration activities within the project. Of course, there have been several dissemination activities, which includes also collaboration with the Solar Key Mark network, which is very important for the manufacturers since it has to deal with product certification across European Union and beyond. Also, a technical visit to a passive building was implemented, as well as several presentations and events such as the Verdatech in Athens and Forward Grain exhibition in Thessaloniki. And a capacity building event in Cyprus took place, and it's planned also a summer school in the National Technical University of Athens. So here, lots of collaboration and activities, followed by presentations, of course, publications, I'm sorry, at the ICRIS conference in April, and later in this year at the ASTRAE conference in Athens, as well as several public publications in journals. So what's coming in the next months? For sure, the second prototype will be constructed, and this activity is about to start, as well as the testing and monitoring of the second prototype, the certification, which is also key, and the implementation of further cross synergies and dissemination events. So let's see, the product is developed. Once the second prototype is ready and it's certified, and we have an outstanding product, that's, I think, one of the first challenges, to have a sound product that can be very efficient in delivering heat to industrial processes for low temperature, right? What comes next, Hande just mentioned marketing and sales, so that this product has a commercial success. So this is where I have started collaborating with Samler to develop a comprehensive strategy that increases commercial success. And here my part, as part of, I'm a consultant from the industry, is to help them build and create a business plan, including some market analysis, defining our target markets, market entry strategies, and also identification of commercial partners and commercial strategies, right? Because once we have a product, we have to sell it, and we'll have to also plan the way to do it, including all the marketing parts of it. So we'll be working together in the position and strategy for this solution as well, or mainly dealing with all the marketing related activities such as product, price, place, promotion. So to make a sound market entry plan, and also supporting sales. Prior and after the product launch, we will also have a PR strategy to bring momentum, to start creating brand awareness, and to possibly making some collaborations. For that, strategic alliances are also very important, so that we can place this product across several countries and for multiple industries. And here, I think, in case you haven't seen these pictures, these are the results from the last survey made by the agency Solrico in Germany. So these are some examples of the industries where solar heat for industrial processes is having a good response. So this shows how many products, projects have been implemented already. So the good thing for this challenge of commercializing the product is that we have references, right? We have references in several industries. So in all these industries, most of the applications are below 120 degrees Celsius. And then we also have the market. So in which countries at most of these projects. So you can see here, it's a very nice mix of countries in Europe, in Latin America, and even in Asia. So here the challenge is to find the proper target, not only regarding the industry, but also the country where these industries are located, right? And for that, it's also good to know that we have a lot of confidence among the players who are in this market niche, supplying a solar thermal solution for industrial consumers or clients. And you can see here the number of installations has been growing steadily since 2016. And in the coming years, for 2025 up to 2027, the share of solar heat for industrial processes systems is going to, or is expected to grow even more than in the previous years. So these give us a lot of confidence with the fact that we want to place this new solution into the market. And lately, well, we have been hearing a lot about CO2 emissions, but also the reliance on fossil fuels. And I think this is something you all know, but just to remark, Right now, I think we're starting to have a new crisis because of all these issues and wars and everything. So in the end, the industry has to become more independent, has to become greener. And I think becoming self-sufficient in terms of their thermal needs is very important. And this is where we need to place also our messages. And besides the economic proposal that the installer or the company implementing the solution is going to do, because the numbers in the end has to make sense. Also, the branding part for the users is important, right? How is this company going to position itself when it says, okay, I've got this new project, I've got this new installation, I'm becoming more self-sufficient, I'm reducing costs, but I'm also becoming greener and more energy independent. So this is part of the work I will be helping with to the consortium partners. My name is Marisol Oropesa. I'm business and marketing strategist. I'm also a speaker and podcaster, networking. I'm doing several things, but basically I can say I'm a Mexican because I was born in Mexico, but I've been living in Germany for 20 years. My background is business administration. I also studied European studies here in Germany, and I've been working in the solar thermal industry already for 16 years. Half of it for a collector manufacturer in Germany, and the last 8 years as an independent consultant. So I'm part of a lot of international projects and organizations. So hopefully this network and this knowledge is going to enrich the project and also help Samler to have a successful commercial strategy. So if you want to reach out, if you scan the QR code on the top right, you can find all my contact details and social media networks. So that's it from my side. Thank you very much.
Dear Marisol, thank you so much. It is important that you have mentioned several aspects of collaboration, and at SolarHub we do value an encapsulating approach where we're not only looking for technical solutions, we're looking for societal solutions. So and this would be best inputted by different disciplines and different sector, let's say, stakeholders that come together to form a better solution and better encapsulating solution altogether. So I hope this has been a fruitful session for all. Are there any questions from our audience in regard to the challenges presented or any other content that was described before? You can either write in chat. I will just check the chat again for any new questions that may have been raised. Okay. If not, thank you for all the participants. Again, this has been a very fruitful session. It's the first of introducing our second AP program, Accelerator program. We value collaboration within our ecosystem actors. We value collaboration by co-creating together, and we hope to be creating the impact together in a more effective and prolific manner together. If you'd like to follow us and the SolarHub project, we have our LinkedIn site as well as our website available. So please do check out, and please feel free to reach out to us if you have any further questions or any requests on our part. As was mentioned, this is the second of our Accelerator program, where in the first we had some matching of different let's say, entities that were trained to support the industry. Now we're looking at the industry problems. So as you can see, we're trying to look at the industry in a 360-degree manner, where we are trying to integrate all of our constituents in the best manner possible. So thank you again for your time and your commitment to support the ecosystem. We're very happy to be part of this community together. And we hope to raise our impact and our effectiveness together. So thank you all, and wishing everyone a great day. Thank you so much. Thank you.
Thank you.
Thank you.
Thank you very much.
Thank
Bye.
you.
Bye-bye. See you
Bye-bye.
soon. Bye.